Sometimes in chemistry, we work with units that actually have two units in them. For example, with speed, it's 55 miles per hour. So the best way to show this is by doing an example. So if we have 55 miles per hour, we want to convert this to meters per second. So if we take a look, we have miles and hours to convert into meters and into seconds. And so I'm going to start by just creating a t-table with 55 miles on top, and then on the bottom, I'm going to put the time. So on the bottom, I'm going to put the hours. So 55 miles per 1 hour. So we can write a 1, or I'm just going to write it as hours. So then we're just going to deal with one at a time. So at this case, I'm going to go ahead and convert my miles into meters using the conversion factors that they give me up here. So the first thing I see is I'm going to take my miles to kilometers. So I'm going to put miles on the bottom, and I'm going to put kilometers on top. And then using the conversion factor, I can see that there is 1 mile for every 1.6 kilometers. So the miles are canceled, but I'm not quite there yet. I'm trying to get to meters. So what I'm going to do next is I'm going to take the kilometers and put them on the bottom. I'll put meters on top, and then I'm going to use the conversion factor where there is 1 kilometer for every 1,000 meters. And again, just like in all dimensional analysis, this works out that this 1.6 divided by 1 kilometers and miles really means 1. And this also really means 1. So everything cancels. It now has meters, and that's the unit that I need. Now I'm going to deal with time. So to deal with the time unit, I'm going to convert hours. And so since hours is on the bottom, since it's on the bottom, I need to put it on top so it will cancel. So I'm going to write hours on top, and I'm going to write minutes on the bottom. And I know from the conversion factor, and we know from time, that 1 hour is 60 minutes. And so then the same deal, the hours cancel. But I'm not quite there yet. I need seconds on the bottom. So I'm going to put minutes on top, seconds on the bottom, and I know that for every 1 minute, there's 60 seconds. So then to just work out the problem, we're going to take 55 times 1.6 times 1,000 times 1 times 1, which you really don't need to do those, divided by 1 times 1 times 60 times 60. And then we know that the units that remain are meters per second. So there's a meter on top and a second on the bottom. So when we work this all out, believe it comes out to be 24. And then we go back to our 55. So 55 has 2 significant digits. We don't use the conversion factor for significant digits, so we're going to leave it as 24. It is something like 24.4, but we're going to leave it at 24 meters per second is the answer.